Buonasera, buonasera amici di GiovedìScienza.
Good evening to all our friends from GiovedìScienza, Science on a Thursday, and welcome to all our guests that I'm going to introduce. This, in fact, is a repeat, because except for Ricardo Luna, who's now new for the first time here, we were already here with 1,400 students from high schools the other day, and we had a presentation which you're going to be hearing this evening too, with a few adjustments. And it's the idea of future. And here you can see there is a very odd machine that you're going to be seeing here. It's to the far left. And I'm going to start with Ricardo Luna, who's a colleague, a journalist. He's worked for Repubblica, and he still writes for La Repubblica. And he is the director of Wired and managed it for 3 years. He's very interested in advanced technologies and what the future has to offer. And here you will find a paragraph from his book on the leaflet that you received coming in. Davide Gomba, who is at the outer left, yes, near the machine, is the CEO of Arduino. No, it's called Officina Arduino. He is a graduate in communication and technology, and we'll see what he is involved in. And he is certainly going to be talking about one of the important topics that we have this evening. This evening we will be talking about the more advanced technology, the ones in IT and ITC, and the ways of managing this technology in a very free manner, leaving everyone the opportunity to speak and to adapt the software to their information. It's a sort of collective approach, which is the exact opposite of the idea of copyright. We think that the future consists of this: freedom for intelligence and also the access to technology. The guest for this evening is, but in fact the third guest is not really a guest, because he's also the chairperson of Centroscienza, but he's also the organizer of this evening, Raffaele Meo, who is one of the pioneers of advanced ITC, and he is an emeritus professor at the Polytechnic, a former chair of the Academy of Science, and also in charge of the CNR IT projects. The CNR being the National Research Center. Before giving the floor to Professor Meo, I'd like to ask you to explain what this object is. This is a 3D printer, which is very similar to the one that you have in the entrance here, at the entrance of the theater, which you were able to observe. Basically, this 3D printer heats this filament as if, you see, which is a plastic filament, which at a certain temperature is deposited according to the design, and which will be making objects, 3D objects, while we were waiting for the beginning of this. You see, the palette fell, so you also have the possibility to see what's inside these objects, because one of them broke. And here you see we're not wasting all the material, and we have here an object. These are things that we printed over the past few years with different materials. So for instance, this is a nylon glass, so it's flexibility, while this is ABS, and it's much, much harder and stiffer. So these are some of the features which make it possible for youngsters, the youngsters all around the world, that can imagine products and then print them as if it were a 2D printer. This printer has a cost which is around, some of you may be wondering, 1,198 euros. It has an Arduino board, but since it's open source, you can also build it yourself, make it yourself, assemble it, and spend much less. Now let's see a little clip.
Bene, questo era un drone utilizzato per consegnare dei libri.
It was a drone that was used by Amazon to deliver some books, 5 or 6 kilometers from the warehouse. No, it's not. It was Domino's Pizza, I think, but basically it's the same thing. Domino's was also delivering. Yes, Domino's is even more interested. Amazon tried this technique and is thinking of developing it to, in fact, hand deliver or drone deliver its books. There's mechanics, because it's a little helicopter with an electric motor and a battery, but above all, it's electronic, because inside there are sensors, accelerometers, GPS. You have to give the exact coordinates, the point of arrival, and there are a series of different technologies and artificial intelligence which will make it possible, and do make it possible, to pilot it right up to its target. I don't know if we'll have these electronic bumblebees in the future droning around, but I think that in France it has already been marketed, and 500,000 of them, as far as I understand, have been sold. Fine. Now, I would say that with Angelo, we have to understand what is happening. What has happened in the very rapid change, swift change, and what is changing in the minds and in the thinking behind the use of this, from copyright to copyleft, as they say. I'm going to start with a comment which is a very general one, which I think will help us understand a lot of things. In the history of human beings, knowledge has grown according to an exponential rule, a bit like the one which has to do with population growth and the national debt of our country. Well, it decreased yesterday, it decreased slightly, public debt. Well, exponential curves initially grow very slowly. They're virtually flat on the x-axis, and then suddenly they soar. If we want to understand this, think of the big inventions of Homo sapiens. Homo sapiens, which has been on this planet for 130,000 years. In fact, I think it's about 200,000. I heard yesterday in a conference, but things are not very clear. But let's veer on the safe side and say 130,000. It took us about 5,000 years to fly, but before that it had been hundreds and thousands of years to walk, and then but a few years to reach the moon. I've prepared 3 slides illustrating this to project the history of science on a year, that is to say, to reduce 120,000 years of history into 1 solar year. So we would discover that the wheel was discovered on the 18th of November. And we learned how to fly on the 31st of December at 2 p.m. And we reached the moon on the 31st of December at 11 p.m. 66 years were in between the two and between the plane and getting to the moon. Now, this is a summary of the progresses of one of the technology, that is to say, movement. Up above, you see the marathon. He, in fact, ran at 15 kilometers an hour to marathon. Then you see the shuttle, 30,000 kilometers per hour. Notice two things. Progress has virtually all taken place in the century that is just over. And also the measure of progress, which is the shuttle in relation to Philippides at marathon, is in the order of magnitude of 20,000. But we will be able to observe that other technologies have increased at an even faster rate. At the moment in which the curve was about to soar, a new destructive revolution took place, which I have here represented with the Bastille. This revolution has very important features, and here I would like to dwell on 3 points. First of all, the density or the ability to store memory, and you see information devices. For example, a present-day mobile could be built with thermoionic valves, the fundamental parts of the first generation and of the radios that my grandmother and your great-great-grandparents, somebody's calculated, but that a mobile phone, if it were to be built with thermoionic valves, would be as big as the Parthenon. My conference, here you can see, is something which I brought with a pen drive, which I'm very proud of, because it has 8 gigabits, 8 billion characters. But there are some which had 256 gigabytes. Now, that's the equivalent, more or less, of a large library which has 150,000 books. When I began to work 45 years ago, and that was the beginning of IT, I was working under Professor Sartori, and I asked for the funding of the whole year to buy 4Ks, 4,000 characters. All the money for 1 year went to buy that additional memory, which was very important for us for reasons which I can explain later on. Now we have billions of characters, so progress is in the order of magnitude of billions, and all for but a few euros. Yes, but a few euros. And now let us see our calculating ability or our calculating performance. Pythagoras, who knew very well, as we was talking about this with the students this morning, many of us don't know it now, but Pythagoras could calculate the product of 2 decimal 6-digit figures in about a minute. Gauss studied the logarithm tables and improved performance by a factor of 10. But the object which you can see here on the left, which has a number of chips on a single support, has the ability of 1 teraflop. Tera means 1,000 billion. So 1 teraflop of arithmetical instructions with an indefinite number of digits per second. This is the increase of speed, and the increase here is billions of billions. The shuttle is laughable then. The relationship between the shuttle and Philippides is absolutely ridiculous. Yes, because no technology has ever improved so rapidly as IT technology in such a short time, in any case. And here you see the 3rd chapter, which is the speed of the bits, that is to say, say data transmission, I'm starting with the smoke signals, 0.2 bits per second, and then you go to the optical fibers. Here you can see the latest generation, and here, which I've called the diamond of transmission, each one of these very small glass fibers that you can see in the drawing that have a 10 micron thickness, of a cost of 2 cents per meter, 2 cents of a dollar per meter, is able to transmit through very fast light impulses at about 1,000 kilometers, a volume of information which corresponds to 10 terabytes per second, something which is really in the order of magnitude of the entire world. Telephone information. This has led to a great innovation of the product. Each and every object, be it the mobile phone, a car, a washing machine, or a microwave, or a plane, has a part of artificial intelligence which is represented by some small objects on board. The terrible object, I call it terrible because it's a war device, is from the technological point of view wonderful. It's a latest generation plane that no pilot could drive because it is inherently unstable, where the piloting is given to a network of very powerful computers, 80 to be exact. How big or how widespread are information technology objects, the various objects that surround us? Well, let's start counting. Human beings are about 10 to the power of 10 billion. We're not yet there, but we'll get there. Well, for every man or woman living on this planet, there are also 1,845,000 ants. Don't ask me who calculate that and how they counted the ants, but it's not surprising because, for example, surely there are about 10 to the power of 7 ants on the terrace of my house that very often try to colonize my kitchen and sitting room, but my wife fights them back. And in spite of the Geneva Convention, my wife uses chemical mass destruction weapons against them. But for every ant, the microelectronic industry has made available to all of us 10 electronic components that are essential, 10 transistors that are well packaged in the integrated circuits. As if I were to say that for every human being, the industry has 10 million transistors. And now, allow me to see the process innovation. Today is devoted exclusively or prevalently to process innovation. This is an instrument for process innovation, or a tool. At one time, think of the car industry, which here in Turin we know a lot about. At one time, the pieces or parts of a car were hand manufactured by some very good mechanics working on a lathe, one at a time. Now there are machines that are called machining center or something like that, that have a productivity which is very, very high compared to mechanics, but above all, they reach quality levels that even the best mechanics couldn't attain. Assembly is very much the same. Here you see the assembly is done by very complex machines, and there are a number of robots that work and are linked one to the other. About 15 years ago, with Professor Rodotà, I held a conference here in Turin on the future of information technology, and talking about this, talking about process innovation, I spoke about the super paint of Professor Alembic. Everybody was a bit surprised, but Professor Rodotà knew that very well, and I knew that not more than 2% of all those here know what the super paint of Professor Alembic is. Well, the super paint of Professor Alembic was a cartoon in the children's magazine Corriere dei Piccoli, which I had when I was a child. It was magic because if you, in fact, painted a drawing, immediately the object materialized. Here you can see a beautiful bicycle, and then there was the paint, and then the bike was there. Well, the super painter by Professor Alambic is the machine that you can see here to my left, and that Davide Gomba in a moment will be illustrating to you. This happens for better and for worse. So these extraordinary levels of progress have positive implications, but can also have negative ones. What will happen? In 1980, a number of very important people answered positively. That is to say, I'm talking about the Brandt report, which was called Now North and South, a program for survival, promoted by McNamara, who at the time was the chairman of the World Bank, in a famous book that was called A World Challenge by Jean-Jacques Schreiber, and the Mitsubishi Memorial in Japan, and then the Rome report by Péchet and the Paris report. They all suggested that we were going towards a better future, which was basically made up of knowledge and souls. I say soul because in a mental model that usually I use with my students, the world that surrounds us is made up of bodies and souls, atoms and bits. When the products that count are those based on bits, that is to say, a resource that knows no end, knowledge. They used to say industrial products of today and tomorrow will be increasingly characterized by the knowledge content, and since knowledge and intelligence is equally distributed amongst all peoples, as Descartes said, even the poorest country will have the chances to rise to the challenge. I accepted the conclusion in the prolusion to the polytechnic courses 2 years later. The inaugural lesson, which is held every year, that year there was also the minister, who at the time was a woman, and I used the Brandt report conclusion and finished with a slide, but virtually the same, because that one was hand-drawn, which showed an international cooperation based on IT, where 3 citizens from very different countries were working for Fiat, for DEA, and for IBM. Yes, but IBM at that point in this imaginary world was a subsidiary of Olivetti. 2 out of the 3 businesses that we were talking about have disappeared, and I would not like some of the people here thought that I was bad luck, and I am not bad luck, but it's our leadership and also the rules of the devil, as we will see in a moment. Brandt's dream did not come true. The OECD results show that not only the distance or the gap between rich and poor is increased, but also the income differential is increased between rich and poor citizens in the most advanced countries. Why did that dream never come true? For 2 reasons. The first is to do with the market. The second one is the devil's fault. But I would say that mainly it's the devil's fault, because the devil, in fact, has the power, as we know, to influence market rules. Now, this is the cumbersome job, the heavy job of creating souls. I said body and souls, atoms and bits. Here we're starting from a drawing from the bit. That is to say, that object, that in fact is the super paint by Professor Alambic. The terrible object is made out of exclusively out of bits, because all the things that the atoms do it automatically, and it's very, very difficult to do it. God took 6 days to create the universe, and on the 7th day, since he had worked and he had breathed life into Adam, he needed a rest. Well, it's a pessimistic conclusion. I suffer because of a lack of a molecule, the felicity growth factor, which some people have, which guarantees happiness to all beings. I am basically a pessimist, and data would suggest that we have to be pessimistic. But I see elements of novelty that lead me to hope that in spite of everything, we can fight the devil. The first one is the arrival of free software. That is to say, programs that are distributed the source as the programmer has written them, so that anyone can take them and modify them, adapt them to their needs, make copies, redistribute them, and so on. It's an enormous phenomenon, although not very well known. I was saying this morning that Google has started a project to gather all the free software, and they've considered that there will be a mountain of software, about 100 million pages, which corresponds to many billion of source information pages. There is a site, source.org, that collects free source, and there are 1.5 million of core people who work them on 170,000 projects. Let's skip the trade balance. We can talk about it maybe later. But the second important thing, Internet. In the devil's code is something absolutely terrible and false. It says that Internet was the result of military research. It's not true. Internet was the result of very many thousand researchers and experts from all the world who work with the principle of cooperation. The head of Internet is Internet Engineering Task Force, and this has rules. The most important is that everything is free. Participation, you have, if I take part as Meo from Moncalieri and not Professor Meo, scientific principles, ideas, code. The documents that can make up the enormous amount of Internet are called RFC, a request for comments, and it says, write them in the toilet, but write them exact and clear. As I was saying, that Internet, when I talk about Internet to the younger students, I mention the Gospel according to John, when there was the fishing net full of fish. But although there were lots of fish, the net did not break. I talk about the technological miracle because if you worked on the first generation networks a few decades ago, know how difficult it was to have 153 computers talking to each other, while now there are more than 2 billion, that interconnect in a matter of a few seconds and exchange enormous amounts of data. This is the miracle, the technological miracle. And then there's the socioeconomic miracle. That is to say, Internet, in my opinion, is the most important of the human inventions. We will discover this quite soon, just like DNA is one of the most important discoveries. Internet is the most important project creation, because we've never had such a powerful and effective tool for the growth of knowledge and the circulation of it. By the way, having said this morning, I heard the news and I heard that the Pope said Internet is a gift of God. Well, third new thing, free hardware. That is to say, like the board you've just seen, a hardware that is made up of components which we know everything about. Just as we know how they're interconnected and how we know what the basic software is. One of the most important of the hardware projects is called Arduino. And in fact, it was first developed in Ivrea. I consider the fact that it it developed in Ivrea a proof of the genius loci of Ivrea itself. It's proof that started with Avogadro, with chemistry, Galileo Ferraris, electromagnetism and electrotechniques, and also Scoberero with nitroglycerin that is negative but also has some positive facets. And now my conclusion, which I'm going to keep for women privately because my time is now up. There are social implications in this revolution. One of the implications, one of the most important ones, is represented by the fact that women, just as we are on average a little bit stronger, are a little bit more intelligent, and therefore the information society is especially suited to women's work, as well as the fact that women are more cooperative for genetic reasons. But we will be talking about this privately. I have, at this point, finished with... let me just go to the end of that. No, I've pressed something too much. I don't know what I did. But we need the two last slides because they represent the future as I see it, a future which is not based on competition, as the devil says, but on cooperation. Thank you.
Allora, io adesso chiederei
I would like to ask Davide Gomba to give us an idea, more accurate idea, of what a Fab Lab is, in particular what the Turin Fab Lab is, something on Arduino, and then I will give the floor to Ricardo Luna, who will give us an idea of his opinions on what he's heard and a glance into the future. As Professor Meo was recalling, Arduino started here in Piedmont in 2005. This is the Arduino board. Here, right. Which you can buy. It's Arduino 1. In 2005, it looked like this. It was a board that was handmade by a group of youngsters that had met in Ivrea to teach in a school, Interaction Design Institute. As in a joke, 2 Italians, 2 Americans, and 1 Spaniard. I am not one of the 5 because the Arduino team consists of Massimo Banzi, the Gianluca Martini, the Italian, David Metis, and Tom Igo, and David Quartieris. The Interaction Design Institute in Ivrea was a very interesting and beautiful time because it, for the teaching of this subject, because it questions a number of dogmas. One was the self-assembling of tools to develop prototypes. One of them is Arduino, but it's not the only one. Arduino, as a board, is virtually a multiplier. People who traditionally would talk about toys and musical instruments make it possible to duplicate, because very often the information is online. This little girl, Sylvia, is in one way produces content. So she has a blog, which is called Sylvia Show. She lives in the States. She is the opposite because she's 12, and the last thing you think is that a 12-year-old little girl is going to manufacture and weld and so on. But this is what she does, and she's become so important that President Obama invited her about a year ago to a children and science event, which is organized to show people what children can do with science. Arduino makes it possible to do the most incredible things. For example, bizarre ones too, like Michael J. Fox, the shoes of the future. That is to say, the auto-lacing shoes, and now Nike wishes to market them. So this is an example where science fiction has anticipated what happens in the future. Then, this fashion, this is an anti-paparazzi brooch because it makes people who are famous anonymous once again, because if you are wearing this, if the paparazzi start to photograph her, the brooch perceives that, and because the machine has a slight infrared ray, which our eyes can't see, and generates a LED beam or bundle, and so it's impossible to see who it is. Arduino is an open source board. I'll explain what open source means. Makes it also possible to spend much less in developing products, in this case scientific products. A Brazilian boy who didn't have enough money for a pH probe, which is to measure pH of water, built it, manufactured it, and in a Creative Commons released the code online. This made it possible also for other youngsters who can't afford this to go on the net and to reproduce following the instruction that this boy left online to reproduce the product. Very often, projects with Arduino look like this. That is to say, they're prototypes. This is a glove, which is still a prototype. It hasn't been marketing, that is able to translate sign language. So this has been sewn onto the glove. There's sensors that make it possible to understand finger language or sign language, and then translate it according to the inclination of the glove. This product, clearly it's a prototype, it's not a product yet, is then transformed into a product and produced or started manufacturing. Just like, for example, here, recently we've heard people talk about the internet notion. This woman has a band that is able to understand how much the child is moving and sends this onto Twitter, but can also inform the father, say, how much the child is kicking around. Then there are other projects such as this, sensors that see how a plant is, that sends this online, but more specifically, as happened 2 years ago, this had a very big social implication in Japan, because the day after the Fukushima disaster, a group of youngsters in the Fab Lab in Tokyo, in 2 or 3 days, developed, because information was released the week of the disaster, a device which, attached to Arduino, was able to send the radioactivity data on the internet. This was called Safecast, and it's still online. You can see it, and thus they were able to prove something which had previously not been released by TEPCO, that was the company that had managed the disaster area, and by the Japanese government. That is to say, the actual radioactivity. This notion of internet and on the citizens is called a citizen censorship, which makes it possible to give data. And in this case, they were questioned, because when they saw this map, both the media and the government had to backtrack and accept it. All this to say that more increasingly often, Arduino is found in these products, which are the quintessence of the of freedom. This is an Arducopter. The source here is open, and it makes it possible to develop very quickly the development of something. Another example is the 3D printer. This 3D printer, the one which you saw at the entrance, is part of the project, the RepRap project, that was established in 2006 to have printers which are able to print themselves. All the parts of the printer outside were printed by another printer. The Arduino project, as well as being involved in Arduino copters, has also been involved in bigger ones, such as open source ecology, which wants to develop or print the 40 most common machines with open source, releasing information which will make it possible for them to make the 40 most common machines of the industrial society. A tractor, for example, why should a farmer build his or her own tractor? Well, I carried out a research on this, and I see that they analyze this information. Tractors have 6 or 7 producers or manufacturers worldwide, and it's about a third more than what it should be. Very often, to repair a tractor, you yourself can't work. You have on it. You can't adapt it because everything's proprietary, and so you have to have a part sent. But the Creative Commons notions is developed or are developing on physical objects. Farming machinery being a case in point. So what is Arduino? Arduino is a board, but it's also a programming environment that makes it possible for me or anyone to program the hardware, and which is why we're able to produce or manufacture what it is. But it's above all, Arduino is a very big community that meets on the website Arduino, which develops other projects. Clearly, since Arduino has been released in Creative Commons, basically, when we go to Arduino, we can download the electronic designs of the board. Our community over the years has produced a number of other boards that cannot use the name Arduino, which is the only thing that is covered by copyright, but have improved the design of the board. For example, this has created a virtual cycle which makes it possible for us and our competitors to improve collectively and to make the board better and better, and all the other boards too. To go back to square one, I am the manager of Officina Arduino. It's a sort of company that represents Arduino in Italy. Within it, we decided to take machines that traditionally are not accessible, for example, laser machines or 3D printers, and we shared it with the community. We have established FablabTorino. This is a meeting of the members that we had last year, and we share these machines and the information. We are in a co-working center. Co-working means a place where you share, and you can rent a desk where many freelance people and people who have a job on their own rent a desk, but because they rent a place where other people are, inevitably they create relationships that otherwise they wouldn't have created if they'd worked from home. This in itself generates a synergy, which means that we can develop projects between FabLab, Officina Arduino, and the co-working toolbox. We've opened another one in Malmo that has the same features. That is to say, offers people from Malmo in Sweden the possibility of trying things out, and is in a co-working center. What are the Fab Labs? The Fab Labs, the term Fab Lab starts at the beginning of this century, 2000-2001, from the degree course of the Centers for Bits and Atoms. Bits and Atoms, that is a bit of Meo's, also like Meo's thinking, and it stems from the need to create a course that explains how you could manufacture nearly everything. I'm saying nearly because otherwise we would lack modesty, but Fab Lab basically means that good practices can be shared, and a certain number of digital control machines, normal tools, and also boards like Arduino. This has been defined by The Economist the third industrial revolution. Last year's front cover, here you can see this gentleman who's working at his desk, but is also manufacturing cars, airplanes, hammers, anything. This notion was defined as the third industrial revolution, and it is the revolution of the desktop prototyping. That is to say, the opportunity of creating 1, 10, or 1,000 products without having to refer to the tool chain, the complex chain, which was the hallmark of the 20th century. At this point, we have a video that was prepared by some Spanish students that explains in 3 minutes what the economist was explaining, the third industrial revolution.
It all starts with a cup that is broken, and a cup which has an emotional link. It reminds the person on the video about his grandparents or her grandparents and where they had bought it. They had bought it many years ago. It was a part of a production process which still exists, but which can be completely changed. It meant that there was a centralized production, transport, but above all, a design that was centralized. There were 1, 2, 10 people, a team of designers that established the shape of the glass that all the world would have used. Now things are different, but they're also different. He looks online, somebody who's developed a cup which is like his, and with a number of online tools, you don't need to install anything in your computer, you can customize it. That is to say, you can adapt it and you can make it look exactly like the cup, and then he shares it with other people. He downloads it on a pen drive, then goes to a Fab Lab where this cup is reproduced by a 3D printer, slightly different in fact, but basically it's the same. At the end of chapter 1, because the advantage is what we will do in the next future, that the cup is put there, and in this case a little bit of time goes by. Trains continue to go very quickly, and so the cup falls again. The child with a latest generation iPhone has a 3D scanner that is able to recreate the shape of the cup. The interesting thing is that in the short period, we will also be able to intervene in the molecular structure, which means we can transform it in a cup which is exactly the same as the grandfather's, which reminds us about a complex history, but which is much more resistant. The sharing of the idea remains, but at this point, there is a new type of shop, which is the materials shop. So we have a list of materials that we have to go and buy. In this case, it's super glass or whatever. Material shop, which is added to there. Material shop. The grandfather goes to buy with the grandson the ingredients that are necessary to make this cup. And just a bit like detergent, recharges the home 3D printer with the materials, recreating the famous cup. Clearly, after all of this, they're hungry, and so they go onto a bioprinter. This part of the video is something the Italians don't like, but it's as fascinating than this. There are already printers that are printing food, but it's with us now. The cup falls, but it doesn't break because it is part of a process which has helped us improve the molecules which make up the cup. This to tell you what we do at FabLab. I also prepared other slides to tell you what is happening in the world of products. So that is to say, there is a quarterly, which is called a US one, which is called Makazine, sorry. It was established in 2004, and it helped Arduino. And as soon as we were established, it used us as its reference.
the journal tries to circulate in the electronic do-it-yourself, the e-do-it-yourself, an open approach. The slogan which promotes it is the relationship which consumers have in this century. If you don't open it, you don't really own it. Many people near me feel increasingly blocked by the fact that they can't open their products, they can't repair it, they can't do anything with it. In this century, we are surrounded by products that are intended to last 2 years. Mobile phones, printers, so on. All of these products are thought of to last up to a certain point when we then have to change them. Make Magazine in about 2004, and even now, has developed a sort of charter of rights of the consumers where it says that the maker's bill of rights to make a product more adaptable. This is a sort of blasphemous thing because we will never tell Apple, give me, or at least people say it, but Apple doesn't listen. Give me the explanations. How can I open this device? Tell me how I can intervene on a product so that it may fulfill my needs. This is the Bill of Rights, but at the Fab Lab, as well as promoting this approach towards technology, we're also trying to give space to the smaller ones, makers. This, for example, is Mattesmo Potique, who promoted this with very small children, primary school children, telling them what a Fab Lab was. In a Fab Lab, very often we personalize mass products. For instance, this is an iPod Touch. It's an Apple product, since we were talking about Apple, where they remade the casing in bamboo. So it's exactly like the others, but it's completely different. Then there are girls who have come to have a laser cutting of collection of fabrics. I'm going to finish here, and I'm going to leave the floor to Ricardo, because I'm sure that Ricardo will be following on. And, oh yes, I took notes, he says, but I would simply like to finish saying something about what we're going to be doing on February the 15th, which is our birthday. We will be 2 years old, and in celebrating a Turinese who lives in Trent now, Pietro Pilollo, with a workshop of self-production of multimedia interactive boards, whiteboards. You talk about them in your book, don't you? And with this, I've finished.
Sappiamo che sono arrivate dal Ministero molte di queste lavagne interattive che sono costosissime, questa invece...
And here you've also launched Ricardo Luna, because we know that many of these interactive boards, whiteboards, have come, which are very expensive, while this is much, much cheaper, but gives the same level of performance. Unfortunately, the minister was not aware of it. Well, we'll be sending her or him, the new minister, one. Yes, I didn't say it. While the Ministry of Education were buying the very expensive ones, which went to schools where there was no internet, there were people who were making them for half or a third of the price. But in any case, regardless of whether you'd built it or not, you can use it. So it's useless having something you can't use. It's a bit like a black box. Right. What is your feeling? What's the future? Unlike Professor Meo, who I admire, in theory, I'm an optimist. I am, even on days like this when the Pope says that Internet's a gift of God. And it reminds me the title of a book which I published in 2010, which was exactly that. Internet was a gift of God.
But it wasn't a quotation of mine. It was a quotation from the Nobel Peace Prize. I had said that Internet should have the Nobel Peace Prize, and I believe that if Internet is used well, it's the best shared platform of knowledge, which Professor Meo was talking about. It's a tool for peace, and it makes it possible for us to build incredible things, manufacture them. Internet has always been considered easily and wearily. For example, the Prime Minister used to call Google Gogol, and others too. But Curzio Maltese, for example, wrote in Repubblica that Internet is a step backwards in the history of evolution of humanities. And Eugenio Scalfari, the great journalist, said that the real problem that we have in Italy is Internet, because the worst of us surfaces. But this is the attitude that our country has. That is to say, we're afraid of that. It's a problem. It's a limit. So what's the result of that? The result is that over the past few years, we've lost a number of opportunities, in spite of there being many extraordinary Italians that think of Olivetti, but also think of the new ones, think of the extraordinary things that have been made and done in the past few years, and this country is immobile. I think that this is a lack of morality. It's worse than many of the immoralities of our political class. And I remember these figures, which are the ones on the growth of the past 16 years of all the countries of the world, and we're one but last. There's Haiti that had the earthquake, but we had the opposite problem of the earthquake. We had absolutely nothing. There's nothing, no development, nothing at all. So what's the reason why we haven't grown? Professor was saying the devil in the market. Well, I always think that if things are not working, we should look at ourselves, see what we're doing. There's an attitude, and I very often mention it, of the Italian culture, which has conditioned us, and to say that it's the government's fault. And in a country such as ours, if you say it's the government's fault, you're always right, but there's something different, and which is something which happened with Internet, and something that we were told. That is to say, today, we can do lots of things in spite of the government, in the absence of the government, not caring of laws, which doesn't mean we're outlaws, but it means that we can do things on our own. We can, for example, make a website or an application, a glass we can manufacture, we can open a company, we can do lots of things. That is to say, currently, we have the tools to manufacture, make, to produce bits, and it's not expensive. It's so easy to use. With the barrier is much lower. Today I was not here with you this morning when we were at the school, because I teach at the Holden School for Journalism, and I was teaching this morning. So to tell them how many opportunities they have, because we talk about newspapers are finished, that newspapers are difficult. I brought two youngsters that have really surprised me. They're video makers. They're makers in one way, because I discovered them once on Facebook, because they have a documentary which is on the RAI, which is the Italian broadcasting company, 6 installments, and they shot them as follows. They organized the trip. The trip was a bit complicated because they had very little money, and they went to Rome, Istanbul, Moscow, Los Angeles, Charlotte, New York, but in all that, to spend 1 month in the States, they spent 6,000 euros, the two of them, and they shot the documentary with an HD camera. They rented a machine. They went to New York, San Francisco, Los Angeles, 30 hours, which become something which the RAI, the broadcasting company, bought, and they post-produced it, cut it, did everything themselves. This was impossible years ago, because to have a production in the States, you had to have a big camera and other things, and to edit it, there was a special editing room, but currently the editing room is the computer as big as this, with a program which may be something like Final Cut, which simply means that you have to edit it. So to do something of the quality which is necessary to be broadcast on a national broadcasting company, you don't need anything really much, and it's enough to want to. So they are makers from a certain point of view. They're video makers. They did everything on their own, from thought to produce to the final product, everything they did. And this is what we can do too. currently, if we wanted to do it, we could reinvent our jobs. We could reinvent opportunities. We could network with people who are like us and create opportunities. Don't forget that I'm a friend of Enrico Giovannini, whom I hold in great esteem and who's currently the Minister of Labour. And 7 or 8 months ago, we had incentives, and I said, look, it's not that this country will start up with this. This country needs something else, and we have to say it. We have a problem of knowledge and expertise. Over the past few years, for a number of reasons, I went back to study what happened in the 60s with a person that many of you might remember, which was Maestro Manzi, who was a teacher on television. And it was called It Is Never Too Late, Non È Mai Troppo Tardi. The idea is that it was never too late. For what? To start learning, it was a literacy program. And there were a lot of Italians who didn't know how to read and write. So what was the challenge? How could you bring them back to school? There was no way to bring them back to school. So they used television. They decided to have a television program in the evening, just before dinner, so after work, and it was called Non È Mai Troppo Tardi, It's Never Too Late, and it taught people how to read and write. It ended in 1968. When compulsory education had become something more complex and had entered our society, and it was no longer necessary to have a literacy program. But in this way, 1.5 million Italians took their primary school education certificate, and the drive of the boom, of the economic boom, was literacy. And we need something like this. We have something which has been proved, which is called functional illiteracy. Most Italians have difficulty in understanding what is written in the paper. This is part, well, of course, we write very badly as journalists. They don't understand how the table is. It's very difficult to understand how a computer works. We are the worst country in Europe after Romania in terms of computer use, and this is not a problem of broadband. Yes, maybe, but it's a problem of different. It's the approach towards these things. We don't know how to do it. We don't know how to manage these computers. These wonderful instruments, which we've been speaking about, is something which we have a detached relationship from. For many years, all those who were involved in technology were looked a bit like as they were mad, they were nerds. We used to call them nerds, smanettoni in Italian. And but our children, ourselves, we're like that now. The other day there was a statistic which was published with one of the worst countries of the world of knowledge of the English language. Of all the countries of the world, well, what we need is a big program of literacy, digital and not only digital. We need Italians to take Italians back to school. But if I say back to school, most Italians will not understand because they don't understand the expression back to school. So we have to understand that what our real heritage is not another government, but to bet on ourselves, bet on the society of knowledge, and it's not the rich, it's not those who have machines, it's not those who have power. Today, if we're going to invent something like Arduino, you needed the talent and the intelligence of some youngsters. The gentleman who made the maker probably lives in a cellar in Brooklyn. He was a hacker in Brooklyn, and he said, well, certainly we must be able to do it somewhere else. And now, for example, the machine has been sold to another U.S. corporation for an enormous figure. So some people become very rich, but the problem is not whether the Arduino people or the other people are going to become very rich, but that when you bet on innovation, it's beautiful. It's an advantage for everyone. Enrico Moretti wrote something. He's an economist, and it's called The Geography of Work, and it explains how, at that point, the only lever for the development of the world is innovation. Without investing on the human capital, we will not do it. So a city has to invest in innovation, because the innovators create new things and they create progress. Well, the economic advantages for everyone. The barman, too, in that country, the gardener, the dentist, everybody will earn more because it'll be all a byproduct. In the city where Zuckerberg lives and where there are the Facebook people, everybody, even the barman or barwoman, earn more. Where the Kodak closes, even the taxi driver earns less. So clearly, economic growth has fallouts. And we have to say this, these things are not painless. That is to say, the shift from one to the other means that some jobs disappear. It's a fact, they disappear. And we can't stop things. We can't stop things simply because we say we want to stop it. Something that happened in the UK about a century and a half ago, which is like now. When machines came, for example, trains, there was a problem to defend the coachmen. The people, for example, the people who were shodding, the blacksmiths who were shodding horses. How do you do that? These are dramas. These are real
problems, but you have a Red Flag Act. That is to say, yes, machines can circulate in London and in other cities, but behind someone who has to have a red flag. So they can circulate, but there has to be somebody with, because they're dangerous, somebody with a red flag. But this didn't save, in fact, the jobs of blacksmiths, and it didn't stop cars from developing. We can't have red flag laws. We must not be afraid of the future. We have to start investing in ourselves and go back to studying. This means that it's important. What the Fab Labs do is very important. They invent things, but there are places also where you can go and learn things. With the Fab Lab, you have to learn what we're doing. Having said that, we have an attitude in Italy whereby we say, for me, this is too difficult. We have an upside-down demographic pyramid, which means there are more old, and I'm nearly 50. Like me and Meo, we're the majority of the country. The people like him, well, they're the minority. So here, you see, and the ones who are over our age don't use the internet. We do, but we're not the majority of the country. I was born in 1954. The majority of teachers in our schools are like this. Or, for example, public officials are like this. They're usually older. Or the entrepreneurs, the business people, the craftsmen, they're all mostly over 50. So we're thinking of eliminating all this country, their experience, their talent. Are we doing this because we've been unable to say, look, that there's a future here? Try, grab it, seize it. But this is not possible. Or we want to create lonely, depressed pensioners. I saw it with my mother, for instance, who was not an internet nerd. And at one point, I discovered that she was on Facebook, and she said, well, I'm 73. I needed it, and I recreated a network of friendship through Facebook. She found her school friends from primary school. She's tagged. She's learned everything. You may like Facebook or not, but it's very silly. It's very easy. It's not much use to anyone. But think of the impact that it can have for the elderly. It can fight, for example, solitude, loneliness, or it may also be telemedicine and be in touch with your doctor. People, youngsters, will manage, but it's for us too. But they'll leave the country if not. I think startups are very important. I think that youngsters have to start things and implement them. Maybe New York is easier. For 10 years, then startups don't pay tax. Very easy, very simple, 10 years, no tax. But in Italy, some people manage. And so why don't they do it? The problem is we have to invest on the people who don't have startups. We have to say, ladies and gentlemen, we can do it. The Italian genius has always managed. Let's study. Let's compete with the rest of the world. Let's invest in our talent. We have to start from illiteracy. And this is what I'm trying to do. Because this is a country that is immobile from this point of view. We're talking about the digital agenda. Well, some think it's an electronic diary where you put all your appointments, and they've created an agencies. And they haven't done anything for 2 years because they haven't approved the articles of the association. So they've appointed a person who's in charge, but is leaving because he's going to do something else. So everything is immobile. So the problem is the digital agenda is not technology, but it's not just technology, but it's a problem of people. And I'm saying this now, and then I'll finish with this. And in the UK, a couple of years ago, they decided to invest on broadband, which we call it broadband, but in the meantime it's become narrow, because what was broadband 10 years ago, now it means you can't see a video online. It's useless. But in any case, we're still on the original broadband. Now we're talking about ultra broadband. When the UK decided to invest on it, they realized that the north of the UK, that had had very little internet, satellite more expensive, etc., they would died. That all the people who in the north of England, like southern Italy, were cut out. So what did they do? They could have complained, done things. What did they do? They created their own network. They called the people and said, would you please write a project up? They went to the local business people, and I said, if I connect your company to the rest of the country, to the rest of the world, would you pay for part of it? project financing? And they said yes. They still lacked money. They went to the citizens and they had crowdfunding. And I said, if I put your name on a meter of optical fiber, as if you had a kneeler in a church or your name or on a bench in a park, would you give me £5? And they did this. And so they've managed. You don't need optical fibers if you haven't got the moral fiber. So I have to do this. No excuses. I don't care what the government does. We have to do it. If we start looking at Rome, looking to Rome, looking up to Rome. No, we haven't got any more time for your questions, so thank you very much. The last thing I have to say, apart from Luna's book, which you can find and which he will sign, the other thing I have to say is that if you're interested in listening to us again, you will find our conference on the web, and you can re-listen to it. Thank you very much. I would also like to say that our GiovedìScienza has exceeded 200,000 viewers, so it's all very good. Thank you.